So that's what a factorial means. So really what you need to be thinking here, if n is like a number like 5 or 7, I'm coming back to this problem in blue, that means I'm really dealing with, if I start with n plus 1, then I go down a power and I say, okay, this is going to be, I started with n plus 1 and then I subtract 1 because again, you subtract 1, then subtract 1, subtract 1, and then multiply all these together. And then I do n plus 1 and then I subtract 2. And then I do n plus 1 and then I subtract 3. Again, you're just subtracting numbers, right? I'm subtracting 1, then I'm subtracting another one, then I'm subtracting another one. That's what factorial means. So on the bottom, what I have is I started with n. You always start with the number that you're given. If I have 4 factorial, it's 4 times, et cetera, et cetera. So I'm going to start with n, then I'm going to multiply that by n minus 1, then multiply that by n minus 2, et cetera, et cetera. So I'm going to go ahead and simplify the top just a little bit. I'll use, yeah, sure, the same color is fine. So this n plus 1 can't be simplified. This n plus 1 minus 1, obviously, positive 1 minus 1 is 0. So this is just n. This is going to be n minus 1. This is going to be n minus 2. Because things are being multiplied, you're allowed to cross things off on that are the same in the numerator and the denominator. So I see an n in the numerator and the denominator, so I'm going to cross them off. Oh, I see an n minus 1 in the numerator and the denominator. Oh, I see an n minus 2 in the numerator and denominator. And in fact, if I go out towards infinity, no matter how big n is, the rest of these are going to cross off, and the answer here is just n plus 1. Well, I guess I still have to take the limit here. I can rewrite the limit. The limit as n approaches infinity of n plus 1. So this simplified into just n plus 1. And then I guess I don't need to be taking the limit to infinity because we haven't used that yet. That's infinity now. If I plug in infinity, infinity plus 1 is infinity. The main thing that you need to know from this lesson is how to get from here to here. How do you reduce this? I'll play with some more factorials in a bit, but let me try some other examples. Equals infinity. And then if I select things, I can delete things. Okay, cool. Learning how to use the technology. All right, so this is where I give you guys 30 seconds to digest the math that I just gave you guys, to ask questions. You don't even need to raise your hand. You can just unmute your microphone and ask. If there's no question in the next 20 seconds, I'm going to move on to a problem that looks really similar to this, I guess. I was thinking of trying a different problem, but I want to assess if you guys know how to do factorials. All right. Well, I don't see any like that confused faces in the Zoom window. So let's go ahead and try another one. Let's try this one. I'm going to stop writing the limit because I realize I don't really need to be doing that. So what if I do n plus 2 factorial divided by n factorial? What would I do then? This is where someone's going to have to eventually unmute your microphone. Actually, let's do quiet raise hands just in case like someone solves it really fast. I want other people to be able to have time to think about this problem. So if you think you have an answer, you can give me a yes, I guess. That's what we've been doing in the past. So yes, I know the answer. If you have a question means you're raising your hand in the nonverbal feedback. So again, you'll have to click on participants at the very bottom of Zoom. All right, so Teflon thinks she has the answer. Everyone else is hopefully doing your work. I can see your guys' faces like staring down. I assume you're doing work.
One.
Yep, and then you can go ahead and reduce that all at the same time if you want. This turns into just n plus. What's 2 minus 1?
1.
Yep.
Oh my goodness. That's great. And then And n minus 2.
Say it one more time.
N minus 2.
N minus 2.
Wait.
It'd be n plus 2 minus 2. So positive 2 minus 2. Just
So n.
Just n. And then do one more for us on the numerator.
N minus 1.
N minus 1. Perfect. Yeah. So we have the numerator correct, and then this continues on and on and on. There might be an infinite number, but we don't know where it ends, but it does end at 1. Okay. What about the denominator? Did you want to do that as well, Teflon, or can I give it to someone else?
You're just someone else.
All right, let's give it to Gio. Gio, the question again is, what is the denominator?
Is it n?
N? Keep going.
Wait. I don't know.
Then you subtract 1, and I'm going to do times. You got this, Gio. You don't want to do it anymore? Okay. We'll give it to Fiona then.
It's n times n minus 1.
And then that goes on and on forever. Yeah, done. You just keep subtracting the power. And I wrote them in a very specific spot so that you can see that they cancel out. So these ones, the n on top and on the bottom, n minus 1, n minus 1. And then eventually all of these are going to cross off as well, including the ones, which doesn't really matter. And we have our final answer, which is, this is n plus 2 times n plus 1. All right. So now's the time where you guys get to ask questions. If you have a question, again, just raise your hand in the nonverbal feedback. We're still staring at the participants window. Otherwise, I'm going to move on to I guess I'm going to do a version of this because I need at least, like, I'm going for 75% of you need to kind of understand what you're doing here. All right. No questions. I think that's enough time to digest the math. If not, this video will be posted later too. So let's try another one. What if I do 3 times the quantity of n plus 1, and that entire quantity factorial divided by n factorial? I want to reduce this. Again, no limits, just how do you reduce factorials? So I'll give you guys a few minutes to do some work. Eva, you want to take a shot at this?
Sure. I got, well, I did 3 parentheses n plus 1 minus 1.
Did you put the minus 1 inside the parentheses or outside the parentheses?
Inside.
Okay, yeah, so that's actually incorrect. But it's a good point to talk about because, again, this is one of the mistakes that I was making in college still. I think the easiest step to do is to first distribute the 3, and then just like before, subtract the 1 from the entire quantity. So if you had said, put the parenthesis right here and subtracting 1 from that entire quantity, then you would be correct because I'm subtracting 1 from the entire quantity. But first, can you distribute that 3 for us? What is the starting amount?
3n plus 3.
3n plus 3. And then you always start with whatever is given to you. If it's n plus 2, that's the first term. So I'm starting with the first term. All right, and then the second term is going to be subtract 1 from that, and I have
3n plus 2.
Keep going.
3n plus 1.
Keep going.
3n.
Keep going.
3n minus 1.
Okay, we'll stop there. And the general rule of thumb is do enough. And we might have done too many. We might have not have done enough. We'll see. Yeah, so thank you. And you want to do the denominator as well? That's a bad line.
Is it the same, like n times n minus 1 times n minus 2?
Yep. And that continues on and on. And this one doesn't get reduced very much because you can't factor out Okay, so I probably made this a bad problem, but that is the correct numerator, which is kind of the important part. I think a better way of making this problem would have been a 3n in parentheses, because that would have made it so a lot of these terms canceled out. If I did that, how would I do that? Oh, that's kind of cool. If I change the problem just a little bit, that'll make it so that I have a 3n and then a 3n minus 1, and then these continue on and on in the same direction, which would mean they could cross cancel. If I just put n, that doesn't actually work. So these cancel out, and then the answer is all of this stuff. So I can rewrite that again. Let's go like that. Move my participant window out of the way. So this is equal to 3n plus 3, 3n plus 2, and 3n plus 1. Okay, I want to switch things up, and I'll come back to factorials in a sec. Does this whiteboard allow me to have a new page? It does not. Okay, what if I just, okay, it says saved. I'm going to go ahead and clear everything here. So if you want me to not do that, you can say go slower. Otherwise, in the next 5 seconds, I'm going to clear this and do another problem that's basically unrelated to everything that we've been doing in terms of factorials. 5, 4, 3, 2, 1. All right. So let's try another type of problem. Let's try this one. 7 to the power of n plus 3, all of this divided by 7 to the power of n plus 1. How do I reduce this type of fraction? So again, just to make sure everyone is still on the same page, the instructions are solve this problem on your own on a blank piece of paper. If you know how to do it, then you're going to give me a yes. And if you have a question or if you want a hint, you're going to give me a raised hand in that nonverbal feedback under participants. Okay, so I don't want to spend too much time on this one. The general idea is whenever you have the same bases, then you can subtract the powers. So this is a case where I have the same base of 7, which means I'm going to subtract the powers. So I can rewrite this as the same base, 7, and then the top minus the bottom. So n plus 3, and then that's the top, and then I'm going to subtract the bottom, so subtract n plus 1. It's just a rule of exponents type of question. So when I do that math, and again, this middle step, usually people never show, they just kind of do the math in their heads, and they say, okay, well, n minus n is 0, nothing, and then 3, this negative sign is distributed into both of these terms. So 3 minus 1 is 2, so this is 7 squared. So let me try a similar type of problem and see if you guys can solve it. About the same level of difficulty. So let's try 8 to the power of n plus 1 divided by 8 to the power of n plus 2. Okay, so let's call on Gio to redeem himself from the last one. Gio, how do you do this one?
So it has some basis, so you add like everything basically. So it's going to be 8 to the power 2n plus 3.
Really, really close. So the only mistake that you made is the sign should
Oh,
be minus because it's division. But you would totally be correct if I was multiplying this times 8 to the power of n plus 2.
okay. So it's going to be 8 plus 2. Wait, 8 to the power of 2.
Done. You're okay. So still really, really close. And now you made another tiny mistake. So let me write out what's happening. You had n plus 1, right?
Oh, never mind, bro.
You're going to subtract n plus 2. This negative sign is distributed. So go ahead and finish this for me, Gio. You got this. You got this, Gio. I'm not going to give up on you. You got
8 to the negative power of 1. Right?
8 to the negative 1, exactly. So you can write it like this. But for our purposes on Khan Academy in the upcoming assignment, you're going to leave this 1 over 8. Beautiful. Yeah, thank you, Gio. I knew you could get it. All right. And let me give you guys just one more problem to build you guys up for your confidence. Let's try another. Let's do a change of color here too. Is this pink? I don't know. Let's do 2 to the power of 3n plus 2 divided by 2 to the power of 2n plus 1. Go ahead and reduce this fraction. So go ahead and give me a yes and a nonverbal feedback when you're ready to go. I'm going to give it to Andrea.
Is it 2 to the power of n plus 1?
N plus 1. It is. Yep, done. Final answer. Box it. So oh, I don't know what happened to my 8 back there. It should have been 8. Yeah, and I should be boxing all of these. Cool. All right, so you guys have homework that you're just going to write down and send a picture and show me. It's going to be written down on here. So I'm going to go ahead and clear this screen, and unless someone tells me go slower. No one. All right, I'm going to give you like 3 problems. If you can do these 3 problems, then you are done. All right, so let's clear all of my drawings. This is going to be your homework for, I'll call it BC Calc, because that's what you guys are in now. 3 problems. Let's do 7 to, no, not 7. Sorry, too big of a number. Let's do 5, slightly better. 5 times n plus 1 factorial, all that divided by 5n quantity factorial. Problem number 2. Let's do 3 to the n minus 5, all divided by 3 to the power of 3n plus 1. And this one, I'm going to give you guys an asterisk. It's a star. If you can solve this, you are an amazing person that tries very hard at mathematics, and I thank you for your efforts. It's going to be hard, so you guys should know that going into it. It's hard. N plus 1 factorial quantity cubed divided by n factorial quantity cubed. And if you solve these all right now, you can just send me a picture. We still have a minute and 10 seconds left, so I don't think you're going to solve all of these. You might be able to solve 1 and 2 really quickly. Number 3, I want you guys to spend at least 5 minutes thinking about. If you solve it in 3, then obviously you only need to spend 3 minutes. But spend at least 5 minutes. Don't give up in that 5 minutes, and then after that, keep trying. But at least you have spent those 5 minutes on number 3. So after you copy these problems down, you're officially dismissed. Is there someone that can tell me also, if I resize this window, does it resize on your computer as well? Is it nice and tiny now?
It's not that much smaller, but like a little bit.
Is there like, is it surrounded by black space? Like, what does it look like?
Right now there's black space on the sides,
And then if
but
I
not on the top.
and if I make it full screen, then that black space disappears. Let me resize like that. That black space is now gone.
The black space is now on the top and the bottom, but there's less of it.
Oh, okay. That's good to know. Cool, thank you. All right, thanks for coming, guys. I'll see you guys tomorrow.